Hello everyone, welcome back again to our channel Coders Arcade. This is Saurav and I'm very happy to say that we have come live again with our Java DSA classes, and yeah, people, all our the audience has been requesting us to come live again, but due to certain internships, projects and trainings in colleges, I could not come live. So today again I'm happy to say that we are live and we'll be starting our live sessions from today. Okay, so and before starting this, guys, I thank all of you for supporting us. And also, one more thing, guys, we have completed our DevOps playlist. Okay, this has been completed, and this playlist has got lots of love from all our audience, and especially from the VTU students, because this was dedicated to the VTU DevOps lab, and all the 12 experiments have been completed, and therefore I wish all the best to all the students who are actually preparing for the exams. The VTU labs are coming up, right? So I know that. And at the same time, thank you to all the faculties for supporting us who have been learning from our channel so that they can teach the students. It was really a good experience, and I hope you have learned a lot from it. Okay. So all the best for those who are going for their exams. And if you have any doubts, obviously I am there. Post your doubts in the comment section. Okay. So now today's topic is not about this. As we said, we are actually starting with our DSA sessions. Okay, data structures and algorithms. We have already started our DSA journey in Java. So this is our Java DSA playlist only, and this is the live playlist for Coders Arcade. And today we will be discussing a very important topic which is frequently asked in the interviews, and along with that some of its application as well. Okay, we have already learnt about binary search. Today we will be seeing its applications and the types of coding round questions that are very frequently asked in the coding interviews. Okay, this will be our agenda for today. And as I said before starting, let's request all of you to again please subscribe to our channel and hit the bell icon so that you get notified about all latest updates. Okay, and guys, yes, today will be one introductory video where we are actually again starting with our DSA sessions, and from Monday it will be regular. So I promise you that we'll be coming regular, at least 3 days a week we'll be trying to come. Okay, and at the same time, guys, we are really busy with some work and we have lots of internships going on and lots of college trainings going on. That's why it sometimes becomes really hectic for me to come back from college and again start with my live sessions, but I'll try to do it as frequently as I can, and I'll try to finish this playlist because I've got a lot of requests from all of you that let's start this again and complete, and we have lots of topics to be covering. Okay, so we'll do that. Fine. And at the same time, let's do one thing. Let me also open the same video live link in my mobile so that what I can do is I can also keep a track of any comments that you guys are making here. Fine. So yeah, I can see Prisha Mehta says much needed series. Thank you, sir. Okay, so we'll do that now. Thank you, Prisha. I think you are from RNSIT if I'm not wrong. Hi. So let's get started. As I said, we have already learnt about binary search and we have seen the time complexity of binary search also. That is log of n. What we will do today is we are going to learn about some important applications. Okay, so let's do that now. As I said, very important application of binary search that you frequently get as a question in the interviews is finding the square root of a number, that is in bracket you might be mentioned that you have to find the integral part. That means the decimal value if you have, that you have to ignore, not required. Okay, finding the square root of a number, integral part, using binary search. Okay, Sometimes they might not mention binary search, they might mention one more thing, they might mention the time complexity, which is log of n. So either way, if you see binary search or if you see log of n, obviously you will be able to understand that the question asks you to solve it in log n time complexity and also in binary search. Okay, so you should be figuring out like that. So let me just write down the prototype for this. The question will be like this, because see, for example, the square root of 6 is how much? 36 is 6. Yes, 6 6 is 36. So the question will be int, because the return type here is an integer. That's why the question says, try to understand integral part. Even if, for example, the square root of 35 will be somewhere around 5 point something, in this case also you should get 6 as the answer, something like that, for example. Okay, the integral part, we are not bothered about the let's not take 35, let's take 37 for example. Okay, 37. For 37 also, the number or the answer can be somewhere around say 6 point something. That's something, the decimal part we are not interested about. We are just focusing on the integral part, that is this integer part of the answer. Okay, so for that the function prototype will be int binary search. Okay, that means the return type will be int and you will be taking integer n and you will have to return the answer. The answer you have to return. Make sense? This is the target. Okay, so let's try to understand this. And also I'll tell you one more thing. 80% of the colleges, be it VTU oriented colleges, be it any other university, they don't teach this topic. But this is a very important topic when coming to recruitment companies like say IBM, say Wipro, say ACL, or say Infosys. Binary search is one of the most important concepts that you will find in the placement drives, and you can solve around how much? Around 70 to 75% questions in the placement drives using binary search. I will give you some important questions that you can note down, and you will find those questions either in lead code or maybe coding ninjas. You can go through them. If you have any doubts, you can come back to me regarding the doubts. Okay, because in one session we cannot solve all of them. We'll be trying to solve some of them. Okay, so our today's target will be binary search square root. Fine, so let's try to do that. As I said, first point that you have to remember, very important, try to understand, we apply binary search on a sorted array. Okay, for example, the logic is very simple. We are searching a key, say key equal to 5 in an array which is sorted. Say for example, we have 3, 4, 5, 9, 12. This is a sorted array and we are searching for this key which is 5, and based on that we know that array index starts from 0, 0, 1, 2, 3, 4. In that case the answer will be 2. We either go to the left hand side, we go to the right hand side. Everyone knows the logic of binary search, and we first do one thing, we find the mid. For mid we use start and end. The formula, as I said, it will be start plus end by 2. We find it. In this case it is 4 by 2. 4 by 2 equal to what? 2. We got the answer here only, so we can directly return this. Everyone knows the simple idea of using binary search, but in our question, try to understand what is happening. We are trying to find binary search. Say this is the function, or in case of Java, obviously we call it a method. In this case, we are trying to find binary search, but on a number, anything in h n something. Okay, Yes, yeah, precisely she's from RNSIT. Okay, yeah, I got your mail, so I remember that. So, any doubts, anything, please make sure you guys are commenting them, and it can be a silly doubt, doesn't matter, but make sure you ask them here only in the comments, or maybe even after the live session ends, you can come up with your doubts. Okay, I'll be trying to help you out. Fine. So, as I said, we have a number here, not an array, but binary search technically is applied on an array. See, that's the point I'm trying to make out. So, how do you apply binary search on a single number? Can you? Can we? Is it possible? So, try to understand this because of this topic only. Because normally, what happens in the colleges, the basic idea is given so that we apply binary search on a sorted array and try to find a simple key. When we get it, we return the index, otherwise, we simply return -1. Invalid, that because an array does not have -1, we return -1 to show that we did not find the key in the given array. Got it? So, how to apply binary search on a single number? Say for example, the number is n equal to 36. Okay, let's see how to do it. I have n is equal to 36. Always remember, binary search technically says that we will have a search space. This word is very important, and it will help you to identify the questions where we can actually apply binary search in the interviews. Okay, wherever in the question you have a range of data, just remember that word. Okay, range of data, or it can be called search space. Wherever you can get certain range of data which can be an interval from this to this, which is sorted, you can easily apply binary search. For example, I'll tell you, because we find the mid, and based on that either we go to the left hand side or we go to the right hand side. Make sense? Because if the number is less, we go to this side, if the number is greater, we go to this side, something like that. Here, do you have any search space? Actually, we do. How? Because the square root of 36 actually lies between 0 and 36. Correct? It lies between 0 and 36. Here is our array, guys. We got our array actually. See, this is our start point, this is our end point. Simple. So, we got this search space, see, 0 to 36. Makes sense? And if you see, we got the two numbers, our starting point and the ending point. Now, simply we can apply binary search. Let's try to do it to find the answer. And remember, the answer is 6, because we have to find the root of n. Root of 36 is equal to 6. Let's try to solve this. And then we will write the code also so that you can understand and verify this. So, we got our range or the space from 0 to 36. Okay. So, this is our start, this is our end. Okay. In this case, end is actually the number only, e equal to n only. Okay. In case of array, we write 0 to n minus 1. In that case, this is not the length, this is the top level range, the number itself. Okay. Now, let's try to find the mid. Mid is equal to start plus end divided by 2. In that case, it will be 0 plus 36 divided by 2, that is 18. Okay, we got our mid. Now, try to understand what we are trying to find out. We are trying to find out a number, some number x into x, that will give you this number 36, right? 36. Make sense? Number into number, the square of that number should give you 36. So, we got this number. Let's try to multiply this number and see if we are getting this or not. So, 18 into 18. This is a very big number. 324. Obviously, this is greater than our number 36. Yes, it is greater. So, if 18 into 18 is greater than the number n, 36. So, obviously, any number greater than 18, that is say 19 to anything, if we multiply that number, that will also be greater than n. So we are not going to get our answer in either 18 or beyond 18. Got it? Therefore, what does it say? We have to reduce our search space. The search space was actually 0 to 36. Now, I got a midpoint 18. Any number 18 into 18 is not giving you the answer. So, anything beyond that will also not give you the answer. Not possible. So, what do? We reduce the space. We say end equal to mid minus 1. What is the mid value here? It is 18. So, we write end equal to 18 minus 1, that is 17. So, we have reduced our search space now. What does happen to it? It becomes 0 to 17. Okay. So, start is 0, end is 17. Fine. Now, again do it. 17 by 2, finding the mid. 0 plus 17 by 2, how much? 8. Makes sense? Now, try to do it. Same logic we are doing. We are trying to do 8 into 8. How much? 64. Again 64 is greater than our number. Makes sense? 64 is greater than 36. So, we are still not getting the answer. What is the mid? The mid is 8. Okay, 8 also did not give you the answer. It is greater. If 8 is greater, anything beyond 8 will also not give you the answer. Make sense? So, what will you do? Same thing. End equal to mid minus 1. What is mid? Mid is 8. 8 minus 1 becomes 7. Okay, trying to understand. We are actually getting close to our answer now. Fine, we got 0 to 7 now. Start is 0, end is 7. Now calculate the mid again. Okay, so I'll just do one thing. I'll just calculate like this. 7 by 2 will be 3. 3. Observe carefully now. I am now doing 3 into 3. 9. 9 is not the answer. Mind you, 9 is not the answer, but 9 is less than the answer. So, it can be a probable answer. What is our target? It is 36. We got 3 3s are 9. 9 is not the answer. 9 is not the answer. Let me write down once again. I'll say 9 is not the answer, but 9 is less than n. N value is 36, right? So, this can be an answer. As I said, we are finding the integral part. It might not be the exact answer also. Make sense? So, what we will do, we will store 9 into some variable. I will say answer, let it be initially 0. Now, it becomes 36. Sorry, my bad. 3. Yes, 3 will be the number that I will store. Okay. So, this 3 I am storing, but if imagine, try to understand, okay. 3 into 3 is not giving you the answer. It is giving 9, which is less than n, our 36. Okay. So, 3 is not giving the answer. Obviously, any number that is less than 3 will never give you the answer. 2 2s are 4. 4 is not the answer. 36 is the answer. Make sense? So, store the answer and move to which part now? We will move to the right hand side. Initially, we are doing end equal to mid minus 1. Now, we will do start is equal to mid plus 1. Okay. So, the range or this is what is happening, guys. I told you, right? Search space. The search space is reducing. It will reduce more and more until you get the answer. You might get the answer or you might not get the answer. When you don't get it, return minus 1. Okay. Now, let's try to understand. I have 0 to 7. I had 0 to 7. I got mid is equal to 3. Then I did 3 into 3, which is 9. 9 was less than n. So, I said answer is equal to 9, and then start is equal to mid plus 1. Make sense? So, what happens here? What was the start value? The start value is this, the end value is this. So, start is equal to mid plus 1 means mid is our 3, 3 plus 1, that becomes 4. Okay. So, now I have got a new space which is 4 to 7. Make sense? Now, again let us multiply. 4 plus 7 by 2, this is our start, this is our end. How much? 11 by 2, that is 5. integer division. 2 5s are 10. Okay, now again do it. 5 5s are 25. What is our n? Let's write down here, n equal to 36. Not the answer, but close to the answer. Still less than the answer. Okay, less than 36. Update. I got initially answer equal to, it was 3, right? Update that to 5. Move to which side? Move to the right hand side. Okay, so start is equal to mid plus 1. What was the mid? The mid was how much? You have seen 5. 5 plus 1, that is 6. Okay, so we got a new range which is 6 to 7. Okay, this is my start and this is the end. We have actually got the answer now. I'll show you. Just hold on a second. This is not 9. Okay, fine. So I hope you have understood this and related. Now let's do it. Calculate the mid value. The mid value will be, mid is equal to 6 plus 7 by 2. How much? 13 by 2 is equal to 6. Yes guys, 6 6 are 36 is equal to our n value. We got the answer actually. Yes, when you got the answer, return it. Very simple as that. See how we applied binary search to a single number. Hope you have understood this. So now I'll just give you the simple steps again. If our value, let's take it like square. Square equal to mid into mid we are doing, right? If this square is greater than the number, then what is it? We are not getting the answer. So we'll do end equal to mid minus 1. Obviously, we are at this part. Here is the answer. We are at this part. We have to come end equal to mid minus 1. This side we have to come. So we are reducing the search space again. Similarly, the other one, if the square is less than n, then initially we will have answer is equal to 0 or answer equal to minus 1. Let it be like this. Then what do? We are close to the answer. Initially remember we got 3, then we got 5, then finally we got 6 as the answer, right? So what we are doing? We are storing the answer is equal to the mid, this mid value that you calculated, and then what you did? You are pushing towards the right hand side. How we are doing it? Start is equal to mid plus 1. That's all. And gradually once you get the answer, return the answer. Is that clear? I hope you have understood this. Guys, this is very very interesting, and sometimes they might tell you to do some modifications or optimizations to even get the decimal part also. Say suppose I have 37, 37 is 6 point something, that decimal part also they will tell you to find out. Okay, in higher packages, maybe for 12 LPA, 13 LPA, they can ask you this question. For the time being, I hope you have understood this. Any doubts, please ping me in the comment section. At the same time, let's write down the code now. So now you know that either we go to the left or to the right. When we go to the left, no need to store it. When we go to the right, please store the answer. That's the simple logic. Okay. What if the number is not perfect square? Then how will the answer nearest to it be returned? Yes, that is what I showed here. See, this will be returned. For example, as I said, if the number is 26, the answer will be nearest about 5 only. It is the integral part, the approximate answer you will get, not the decimal part. For the decimal part, you have to think about something. You have to do some modifications to your code and you have to do it. Okay, that we will discuss later. For the time being, let's try to solve this logic. As I said, for 37 also you will get 6. For any number which is not a perfect square, you will get the nearest close one. Okay, let's write down the code, then you will be able to figure out. Okay, I'll go to my editor and start writing the code. I hope it is visible. Okay, so let's do one thing. I'll create a new package called binary search applications. Okay, and here new Java class, I'll say square root using binary search. Fine.
Okay, and let's write down static int binary search and int n. Okay, and from the main I'll just call this int binary search and let's pass 36 for the time being. Okay, this prototype will be given to you, you just have to write your code here. Okay, so let's write it, and for the time being the start value as we saw was 0, the end value was the number itself. If you remember, it was n only, right? Okay, now the base case, as we already know, while start is less than equal to end, let's take the answer as well. Int answer is equal to, let's take -1. Okay, so as I said, what were we doing? I was taking a variable square is equal to mid into mid. For that we have to find the mid, right? So is equal to start plus, all of you I guess you know this formula, end minus start divided by 2. This is the optimal formula for finding the mid. I have already told you about this in the previous videos. If you haven't watched that, please go ahead and watch this. And also if you want, if you know the answer, please comment that in the solutions. Why are we writing start plus end minus start by 2? Okay, and square equal to, what is it, mid into mid. Fine. So as we discussed, if our square is greater than the number, then obviously we are going out of bounds. Actually, we are not on the proper side. We'll just say go to the left part. So how do you go? End equal to mid -1. Find else if, okay, so in that case what do you write? What was the other case? Tell me, anybody. The other case was if our square is less than the answer n. In that case, what do? We go to the right hand side, but we store the answer first. We will say answer is equal to mid. Then we go to the right. Let me write down. Go to the right hand side. Start is equal to mid plus 1. Okay. Makes sense? We have done both of them. Otherwise, there was one more option. Else, let's write the other condition. That condition is what? We can also modify it like this. Let me write here as else. This will be the else if block and this will be the else block. And here let me write if our square, the first condition equal to the mid, then obviously we will return the mid, right? Return mid. Fine. See, in the else block I don't have to write this part, not required. Hope you have understood this. See, first condition I will again discuss. If it is equal to, we are returning mid, which is the answer. If I go back, if you see at this value 6 6 the 36, we are returning the answer, right? So in that case, what I have done, I am returning the answer like this. If it is greater, go to the left hand side because we are not near the answer. If it is less, then actually we have not found the answer, but we are close to the answer. That is how the numbers which are not perfect squares will be handled in this block. Make sense? So now try to understand. If at all we are not finding it, obviously we have to return answer, which is invalid answer, that is -1 only. Okay. So now let's see. I will just run this and check if it works or not. For 36, the answer should be 6. Yes guys, see here, this is the answer. Very simple. Hope you have understood this. That is how it is triggered. Okay. As I told, we are actually storing the numbers which are not the answer also, right? In that case, for you also, Prisha, when you are asking that, this is not the answer, close to the answer. In some cases, this will also be stored. Okay. That is how it is handling it. And if you see here, if I write 37 also, let me copy the same line and let me paste it here and say 37. For this also you will be getting 6 as the answer. See, makes sense? That is how it is working out. The last else block where you are actually going to the right, you are storing the answer somewhere. That's answer is actually the approximate answer for a non-perfect square number. That is how it works. And obviously the time complexity is log of n only, because you are directly using binary search as an application to find the square root of a number, and you are actually finding what? You are finding the integral part of that number. Okay, hope you have liked it. Guys, one more thing, if you guys are here in the video along with me in the live session, please, if you have not subscribed, please just don't watch the video and go back. Please subscribe to the channel and hit the bell icon, because we'll be coming up with lots of good content like this, and there are lots of topics left. We have only started. This is the 6th video only. We'll be starting with linked lists, we'll be starting with trees, graphs, BST, and lots of other topics. Okay, so stay tuned in the videos, and any doubts, anything, please make sure you ask them so that you can understand. Okay, I hope you have liked it, guys. What I'll do is I'll share all the codes whatever I've written in a GitHub link very soon. Don't worry, and you will be able to find that in the description of the videos in the next video. Fine. So hope you liked it. Any doubts, feel free to ask them in the comment section. Now, is the doubt clear? Yeah, Naveen says don't give up. Yeah, obviously. Now, if you are clear with this, let's go with the next one. Let's try to understand the next topic, as I said. So now we have found the binary search square root. Okay, now we'll go to the next one, which is what? The next one, we'll do it in the next session, but I'll give you a simple idea about it. Okay, so let's try to understand the logic. I'll just give you the logic and we'll be discussing the solution in the next one. Okay, so let's go back here and try to understand what I'm talking about. As I said, the topic is first and last occurrence of a given element in a sorted array. Very interesting topic, very important topic as well for placements. Okay, so the question goes like this. I have a sorted array like this. Int ARR is equal to 1, 2, 3, 3, 3, 4, 5, for example, and this is index 0, index 1, index 2, index 3, index 4, 5 and 6. Fine. So imagine someone says the key given is 3. You need to find the first occurrence, you need to find the last occurrence, and you find the total occurrence. Okay, how will you find it? Very simple, and also they will be mentioning log of n. That means you have to use binary search. Okay, so how will you do this? It is a sorted array. It has to be a sorted array. Otherwise, obviously, you cannot apply binary search. This is a very interesting question. I will just give you the idea and we'll be talking about this again in the next video. Fine. Try to understand. first occurrence, last occurrence. Okay, so same array I'll take 1 2 3 3 3 4 5 6 for example, 1 2 3 3 3 4 5 6. The array can be anything, doesn't matter. 1 2 3 3 3 4 5 6. Okay, the key given in both the cases is 3. Okay, and let's write down the indexes. 0 1 2 3 4 5 6 7, 0 1 2 3 4 5 6 and 7. This is the start value, this is the end value, this is the start value, this is the end value. Okay, so what actually happens? You are trying to find the first occurrence. First occurrence will start from the left hand side. So the actual answer is how much? 2. At index number 2, this key 3 occurs for the first time. And last occurrence will be from the right hand side. That means at index number what? 0 1 2 3 4. Yeah, here. At index number 4, the key 3 occurs for the last time. Got it? How will you solve this? Same example, guys. Find the mid. Mid equal to start plus end by 2. How much? 7 by 2. That is 3. Okay. First condition that we write. If our ARR of mid is equal to the key. Yes or no? In that case, mid is 3. So ARR of 3 is equal to what is the key? Key is 3 only. What is ARR of 3? 3 only. So it is matching. If it is matching, remember, if it is matching, the first occurrence is always at the extreme left hand side. Please remember, extreme left. And the last occurrence will be at the extreme right. So what we do, we store the answer. I'll just say answer is equal to mid. Initially, let's say answer equal to 0 or minus 1, doesn't matter. Answer is equal to minus 1, an invalid index where we don't have the array element or the key. Okay, show the answer and move to the extreme left. How do you do it? You will just say end equal to mid minus 1. So you are going to the extreme left hand side. Got it? In this case, same thing. If our ARR of mid is equal to the key, in this case it is yes, because ARR of 3 is equal to 3. The answer is correct. Fine. What you do? Store the answer. Same thing. Answer is equal to mid. Now you have to go to the extreme right, this side, because the last occurrence will be at the extreme right. So how do you do it? Shift the start. Don't shift the end. Here you are shifting the end. Here you will shift the start. Start will come after the mid, beyond here. It can come here. Make sense? It will come here. So start is equal to mid plus 1. That's all, guys. Other things are simple. Same as that. Make sense? This is how it will automatically keep on going to the extreme left to find the first occurrence. Once it finds a match, it will stop there automatically, because we have the base cases, right? We'll say start is less than or equal to end. Because of this base case, automatically it will stop at a certain criteria. Otherwise, you already know, if you are not getting the answer, either you move to the left or to the right. Those else parts will be absolutely same. Here also it is same. Got it? This is how you will find the first and the last occurrences. Shift to the extreme left or shift to the extreme right. That's all. And after you have found, say for example, you have found the first occurrence equal to how much? 2. Okay, yes, second index, and you have found the last occurrence. The last occurrence is equal to how much? 4. Okay, then how do you find the total occurrences? What will be the formula for total? Let me write it down somewhere bottom. You found the first, you found the last. Total occurrence formula. Total occurrences formula will be how much? If I do last minus first, LO minus FO, will it work out? Let's see. 4 minus 2, how much? 4 minus 2 is 2. This is not the answer, because the total number of occurrences for that element is 1, 2, 3. 3 occurs 3 times. If you see 1, 2, 3. So that is not the answer. What is the answer then? The formula has to be manipulated or changed. You will have to add 1 plus 1. So what will be the formula? Last minus first plus 1. So ultimately it becomes 2 plus 1. 4 minus 2 is 2, 2 plus 1. How much? 3. So once you have calculated the first occurrence, the last occurrence, finding the total will be done using this formula LO minus FO plus 1. Fine. Time complexity as usual, you are using binary search, it is log of n, faster than the other searching algorithms. Fine, hope you have understood this. This code will be writing in the next video, the next session, which will be, I hope, let's see if I can come tomorrow or else it will be on Monday. Hope you have liked it, hope you have understood the concept. If you really liked it, please post your comments in the comment section and also stay tuned and ऐसे मत भाग जाओ, अगर समझ में आ रहा है तो सब्सक्राइब भी करो. Fine, if you are really liking it, please subscribe guys, please subscribe.